Hello and welcome to KISS Math. Here we will cover multiplying and dividing fractions. Now if you can add and subtract fractions, then multiplying and dividing will be a breeze. However, there are a different set of rules to follow. Let's look at multiplication first. So we have 3 over 4 times 4 over 5. And I can write these fractions with the multiplication sign, but sometimes this can easily be mistaken for the letter x. So a better way to write this is without it. So 3 over 4 times 4 over 5, like this. And now when you multiply fractions, you don't have to worry about least common denominators and adding up the numerators. All you need to do is multiply straight across both the top and the bottom. If we do that, we would have 3 times 4 over 4 times 5, which would be 3 times 4 is 12, and 4 times 5 is 20. So this is our answer, but we need to check if this can be further reduced down, which it can. If we divide both the top and the bottom by 4, we would get 12 divided by 4 is 3, and 20 divided by 4 is 5. And now this is our final answer. But what does this even mean? Well, we explained what it means to multiply regular numbers, but it might be harder to visualize fractions since they're not as clean or even numbers. Sometimes decimals can help, and a good way to demonstrate decimals is with dollars and cents. A dollar can be split into 4 quarters, and if you have 3 of those quarters, you would have 75 cents or 3/4 of a dollar. You could also call this $0.75. Now, if you have 75 cents and multiply by 1, then you could say that you have one set of 75 cents, or 3/4. If I multiply my 70 cents by 2, then now I have 2 sets of 75 cents, or a total of 6/4, which would be a total of $1.50. And if I multiply my 75 cents by 3, then I bring 3 sets of 75 cents, or a total of 9/4, which would be a total of $2.25. And you get the idea now. But if I multiply 75 cents by 4/5, I'm multiplying by something that's not even larger than 1, which means I don't even end up with one set of 75 cents, only 4/5 of 75 cents. You see, I'm missing part of a quarter here. But what exactly is 4/5 of 75 cents? Well, we said that 3/4 is the same as 3/4 of a dollar. And we also just calculated that 3/4 times 4/5 was the same as 12 over 20, which when we reduced that became 3/5. And if you convert 3/5 to decimals, that becomes 0.6. And when we're talking in dollars and cents, this would be 60 cents. So 75 cents times 4/5 would be 60 cents, which is good since we were expecting an answer less than what we started out with. So fractions just give you a way to multiply something that isn't a whole number. It would be like instead of buying a full deck of cards for $4, you buy just one suit or 1/4 of the deck for $1. Now you had to multiply the price by 1/4 to get $1. Dividing fractions is almost the same as multiplying, except you just have to do one extra step. So for example, if we have 3 over 4 divided by 1 over 4, whatever fraction you're dividing by, you have to flip that fraction first and then multiply it. Now I know the thing says to divide, but that's why we're doing the flipping. So here, since we're dividing by 1/4, we have to take this 1/4 and flip it. So this 1/4 becomes 4/1, and then we multiply it. So what we're going to do is we have 3/4 times 4/1. And we'll multiply across the top to get 12, multiply across the bottom to get 4. Both of these are divisible by 4, so this will reduce down to 3/1, which is just 3. Now, just like I don't really like using the multiplication sign, I don't really like using the division symbol either here. I just kind of did it for demonstration purposes. A more common way you might see this is like this. 3/4 over 1/4. Now you can still do the same thing and flip the 1/4 multiply, but what I like to do is multiply the outer numbers here, so 3 and 4, and I'll put that as the top number, which is 12. And then I'll take the inner numbers, 4 and 1, multiply those, and put that at the bottom. And again, I end up with 3/1, or 3. And that's the final answer. Alright, so that's the mechanics of dividing fractions, but let's try and visualize what we're actually doing with the number line. If we do something like 6 divided by 2, we are asking ourselves, okay, how many times will 2 go into 6? Well, 0 to 2 is this amount of space here. And then here's another 2 here, from 2 to 4. And then from 4 to 6 is another block here. So we can say that 2 goes into 6 3 times, which makes perfect sense. So then let's go back to our example of 3/4 divided by 1/4. Well, we can do the same thing. So here's 1 over here, and then half of that would be 1/2. So here's 1/2, and then half of that would be 1/4. So here's 1/4, and then in between, we'd have 3/4. So we're asking ourselves again, okay, how many times will 1/4 go into 3/4? Well, here's 1/4, and here's another 1/4, and another 1/4. And then we've made it to 3/4. So just like 2 went into 6 3 times, we can say that 1/4, represented by this distance, goes into 3/4 3 times. And this, if you remember, was the answer that we got last time. So that's how we can visualize what we're doing when we're dividing fractions. And as you can see, it's not that much different than dealing with whole numbers. It may get a little complicated when we start throwing in variables and terms, but the concept will always be the same. So that covers multiplying and dividing fractions. If you want more examples, I'll link a separate examples video down below.